Okay, well, I hope everybody's having a good day. What is happening tomorrow? Okay, you got your exam. The one change I've made to the test is I did remove the compound and the simple interest problems. I'm going to go ahead, most likely turn it into a quiz or something like that for next week. I'm not going to be here Friday, or at least that's the plan right now. During class on Friday, the substitute will go ahead and pass out the assignment for compound and simple interest, and we'll go ahead and let you work on it the whole period, help each other out, do all that good stuff, and then we'll turn it in on Monday. Okay. But as far as the test goes, Haley. Okay. My next question was going to be, what will the test cover? Okay. So it'll cover what? Geometric sequences and series, not arithmetic. Systems of equations. Okay, quadratics. And then currency conversion. Yes, there we go. So those are going to be the 4 topics on there. So just a lot of algebra, really, when you get down to it. If you have any questions, Eli? I will let you use your notes. Okay. A lot of information on that test, so I'm going to let you use your notes. I would encourage you, make sure you're familiar with your notes. You don't want to lose time, flipping back and forth and not being able to work the problem. So it's still a good idea to look over your material. So that's happening tomorrow. We talked about Friday, and I think that's all I have. Emily? Okay. I've got that right here. Okay, so on Monday, let's see, Emily, it looks like you signed up for Tuesday in class at 1:25. Okay, all right. In fact, it looks like the very first person I will meet at 7:30 Monday morning, Araya. So you remember you signed up for that, right? Okay, so everybody who signed up for Monday, Araya, Alejandra, Gabby, Eli, and John. Okay, so that's all the folks I'll be seeing that day. Okay, so basically you'll have the entire week next week to work on your IA. I'll have the Chrome cart open. I would encourage you to go ahead and bring whatever materials you need. If you want to use your own laptop, that's perfectly fine. So if I'm, not meeting with you at a particular time, just go ahead and continue to work on that IA and do what you need to. When's it due? Okay, March 7th, okay, the Thursday right before spring break. So I think at this point we have, about 6 weeks? 6 weeks left before the IA is due. So you still have a lot of time, but really when you think about the big picture, not a lot of time. So just let me know if you have any questions on that. Okay, let's get to simple and compound interest. It's been several days since we really had the opportunity to talk about this. We had simple interest, I equals PRT, where P is the principal, R is the interest rate as a decimal, T is the time in years, or you had I equals CRN divided by 100, where R is still the percentage, but it is going to remain a percentage. The 100 is what would change it to a decimal. The C is the principal you would begin with, and then N is the number of time periods. Then we started looking at annually, which lengthened it a little bit. If you want just the interest, you subtract off the original amount. But basically, C times 1 plus R divided by 100 to the power of N, where N is the number of years, R again is the percent that you're going to be getting annually. Okay, and then C, of course, is the amount that you input, or I should say begin with. And then, I believe after that, we started talking about compounding periods. And I think we were able to get away with one example. Okay, so the formula now, C times 1 plus R divided by 100K to the power of Kn. So the power, as we said previously, that number was the number of times interest was going to be applied to your amount throughout the life of the investment. And K is also going to be multiplied by the 100, which we're dividing into the R. So R here is going to stay the percentage. Okay. Now, we have several of the problems to work. Now, I'm going to go ahead and take a couple. I want to show you how to use this financial calculator on the Inspire. Now, I always like to do it the old-fashioned way. I'm big on the formulas. probably because I'm a math teacher. But this is a pretty handy little item. You can go ahead and play with it, ask me questions if you need to. But the ones that I've highlighted here are really what you want to take a look at. So it says the number of time periods, but it's the number of compounding periods per year times the number of years. That's what you want to input for that variable n. Okay, then the percent, you want to put it in as a percent. When you input it, you're not going to put it as a decimal. PV represents the present value. That's what you're going to originally invest. FV represents the future value. That's a lot of times the answer that you're looking for. And then PY and CY represents the payments per year and the number of compounding periods per year. So really all you're going to need to do is plug in, and I believe in the calculator it's PPY. But as soon as you plug in a value for that, it automatically uses the same value for CPY. Okay, so let me go ahead and show you this. Oh, the only other thing, and I underlined this so I wouldn't forget, when you go ahead and plug in the present value, we always enter it as a negative. Okay, the reason we go ahead and do that is because once you invest it, do you have that money anymore? No, so it's considered a negative for your situation. Does that make sense? Okay, so let's take a look at this. Consider an investment of $10,000 at 8% annually, compounded annually for 9 years. Determine the value of the investment at the end of 9 years. Okay, so if I were to go ahead and write this out, let's say that the amount after 9 years, so I start with what I'm going to invest, the $10,000 times the 1 plus. Now, because we're doing this annually, we don't have to worry about the K. All right, K would just be 1, so it's not going to change anything. So I'm going to go ahead and put the 100 here. What percent am I getting? 8. So I want to make sure to leave it at 8% because the 100 is going to take care of that decimal for me. And then I was wanting to leave it for 9 years. Okay. So if I were to go ahead and plug all this in, let's see what we get here. So 10, and this is going to go a lot faster if I plug it in with the mouse, because I'm going to come over here and do this anyway. And there's some tangent ratios if you're interested in that. We are actually going to be doing trig in a little bit, so you will be seeing stuff like that. So let's see here. 10,000 times 1 plus control divide. We had 8% over the 100. Let's get out of there, raise it to the power of 9. Okay. Once a year for 9 years. So if I go ahead and push enter, okay, control enter, okay, and let's see if it actually gave me any decimal places. There we go. So about $19,990.05. Okay, let's go ahead and say. Would everybody agree? Now let's go ahead and plug it into the financial planner. All right. So here's how we're going to go ahead and get there. We're going to go to menu, finance, okay, and then finance solver. Okay. So let me get back out of there. How do I get there? Menu, finance, finance solver. Okay, so here's all the values that I previously described to you. So N, remember, that was a product of the number of times you compound it per year times the number of years you're going to leave it. Well, we're doing it once a year at 9 years, so it's just 9. Okay, tab. Now, we were getting what percent? 8, so I'm going to type in the 8%. The present value, how much did we invest? Negative 10,000. You want to plug it in as a negative, so I'm going to click negative 10,000. Okay, we don't have to worry about payment. Okay, the future value is what we're wanting. Now, how many times a year were we going to do it? Now, that was the total number over the life, but we were only going to compound it once per year. We're going to compound it annually. So as soon as I push in 1, it'll automatically, whoop, sorry, put that in the wrong one. Why is this thing not moving? There we go. Okay, so PPY, it's already 1, so I'm not going to go ahead and change it. We don't need to worry about payment. And now we're looking for how much we're going to have at the end. Now, these problems can also work backwards. If you want a certain amount and want to know how much to invest, you could change this to the beginning. Okay, but we're looking for the end. Now, here's what you're going to do. We got all of our values plugged in. If I put the cursor in the tab that I want to find, okay, I want to know what the future value will be with all of these. If I go ahead and push enter, it'll go ahead and give me that amount. Unable to calculate future value. Oh, I wonder if it was because I had that. There we go. Okay, supply missing information.
You need a 0.
I must have actually, sorry about that. I'm not making any additional payments per year. There we go. There you go. So like I said, I mean, this is a pretty cool little tool. The reason it didn't work is because I accidentally had erased the payment when I was trying to put it in as PPY. But, I mean, if you want to play around with this, I mean, I think it's great. I, again, personally like the formulas. I'll go ahead and do one more of these with the financial planner. Okay. So I'm going to escape out of here. Let me get rid of all of this. Okay. So let's go ahead and do another problem. Okay. So let's try this one. Finding the present value of an investment. Okay, so the present value or principal is the amount of money that we invest now at a given rate over a given time interval so that it will amount to a given future value. So here's my example. How much does Helena need to deposit into an account to collect $50,000 at the end of 3 years if the account is paying 5.2% compounded quarterly? Okay, PA stands for percent annually. Now, because we're compounding it quarterly, I'm going to need this formula. C times 1 plus R divided by 100K to the power of KN. Okay. So the way I was taught was always to go ahead and, use the formula. I kind of work backwards. That's why I kind of like to do so. So we want to end up with 50,000. So we don't know what the initial value is. So let me set this up. 50,000 is equal to, well, we don't know what C is, times 1 plus, okay. What percent am I getting? 5.2. Okay, so I'm going to go ahead and click 5.2, or write in 5.2. Now remember, we're going to divide that by 100K. We're going to go ahead and compound it quarterly. So that would be 4 times a year, so every 3 months. So what would this be? 400. There we go. 100 times the 4. And then I'm going to raise it to the power of Kn. Okay, so K times N would be that 4 times, how many years are we going to leave it? 3 years. So it looks like my power is going to be 12. Okay. So we're going to apply interest to whatever value I input 12 times over the life of the investment. So hopefully whatever I invest with this information is going to get me to the 50,000 that I need. Okay. So now I'm going to take all this information and I'm going to go back to my finance solver. So here's my calculator, menu, finance solver. Okay, so what is the value of N? Oh, not 3. Remember, N was a product of the number of compounding periods and the number of years. So we're going to write 12, that power we placed on there. Okay, we were getting 5.2% interest. Okay, we don't know what the present value is. That's what we're looking for. So I'm not going to worry about changing payment this time. The future value, we want it to be 50,000. Okay, now the PPY, this is the number of compounding times per year. So how many times are we going to get it? 4. And you'll notice, see, it automatically changes CPY to the same thing. Okay. And we're going to go ahead and do this at the beginning. And I really actually don't believe it changes if you leave it at the end, but we're looking for what the beginning investment should be. So now I'm going to go to present value. And I'm going to go ahead and erase that. I'm going to push enter. So how much should I invest? $42,820 and let's say like 99 cents. Okay. And you'll notice it's negative because that's the amount of money that you have to invest, so you don't actually have that. That's why it's considered a negative to you. Okay. And we could check that real fast. 42,820. Okay. So let's do this. Oh, what am I doing here? Sorry. Let's go back to the calculator. 42,000, was it 820.99? Parentheses 1 plus control divide. We were getting 5.2% over 400. Bless you, because we're going to do it for 4 times a year. and then I was going to raise that to the power of 12. So if this is correct, it should be getting me really close to what? 50,000. There we go. So it's giving me like 50,001 cent. That 1 cent's important. Okay. All right, questions. All right. Hey. No. It's going to have to be negative for the calculator if you decide to do it that way. But for my answers, no, I'm not going to worry about that. In fact, like I said, that financial planner is great. I never really use it myself. In fact, I was only introduced to it a couple of years ago, which is why I probably don't use it as often as I should or as I do. But did anybody want to go ahead and try to solve that any other way? I mean, what would be another way to solve this problem? You could just solve for C. You could type it directly in the calculator. Or I was even thinking numerical solve, okay, where you type in the equation. Should be able to work backwards and figure out. I would just change C to X. Okay. So any questions on the financial solver?
I guess I'm getting a little confused.
Well, remember, there are different formulas. So are you talking about how to know when to use what formula?
Yeah.
Well, it depends. The only way your formula is going to use the variable k is if you're compounding it more than once a year. Okay, so this formula right here, A is equal to C times 1 plus R divided by 100 to the power of N. This is if you're only going to do it once. I was going to say once a year. I'll write it out. Why not? Once a year, as opposed to if I were to say C times 1 plus R divided by 100K to the KN. And this will be K times per year.
What about the one where it's the one involving
Oh, that would just give you the interest that you've earned. So, for example, let's see, let's go back up here. Was it this one? Like this one? Yeah, this one is just the interest. Because, see, you'll notice what you're subtracting off is the initial investment. So however long you happen to leave it in, however many years, that just gives you how much money you've earned, how much it's grown. So if you don't worry about that minus C, well, then that's the total amount that should be in your account. That's including what you invested. Okay. Any other questions? Okay. All right. Well, for the rest of these, I'm going to go ahead and just use the formulas, okay? And if you want to, like I said, play around with the finance solver, or if you even think you need to use it, okay, please feel free. All we got to do is finish up. We don't have a whole lot of examples left. I think we're done. Okay. So finding the time period of an investment. Often we wish to know how long we must invest money for it to grow to a specified sum in the future. For how long must Magnus invest $4,000 at 6.45% annually, compounded half yearly, if it's to amount to $10,000? Okay. So basically we want to earn $6,000 and we're wanting to know how long it's going to take for that to happen. So let's identify all of our values here. 4,000 is what we're going to invest, so that's my C. The 6.45%, that's my R. Compounded half yearly, bless you. So what does that mean? That is every 6 months, so K would equal 2. So that's the same as saying biannually. There are usually different methods of saying that. And this is my future value. Okay. Or A, if that's what you want to go ahead and call it. So what are we trying to find here? What variable? N. We want to know how much time it's going to take to do so. Now, because we are compounding it more than once a year, we're going to be using the formula that I had just written. And I believe, was it at the top of this page? Okay, I'll just go ahead and write it out again. A is equal to C times 1 plus R divided by 100K to the power of N. All right. And let's go ahead and plug in everything we have and see what happens. So we want to have $10,000. Okay, we're going to go ahead and start with 4,000 times 1 plus, we're getting 6.45%. Okay, over. Now, we're going to go ahead and compound this twice a year. So what's my denominator? 200. 100K. So 200. And then to the power of K times N, well, we don't know N, so I'm going to go ahead and put 2N. Okay. We're just solving for N. Okay. Which would make this an excellent problem for what? Logarithms. Okay. So we'll go ahead and run through it, by hand first, and then we can go into the calculator. Okay. But if these problems, are a little confusing for you, just keep at it. Okay. With experience, it's going to get better. Even sometimes when I walk in, some days, 2n plus 2n is just 4n to me. Sometimes it's just 4n to me. See, I remembered that joke because of 2n. Yes, John.
Would you recommend us using a financial calculator or the?
That's completely up to you. I mean, you're going to have the calculator when you take the paper exams. So if you practice on it and you feel really confident, I'd go for it. Like I said, I'm old-fashioned. I like the formulas. I like the math. And who doesn't, right? Exactly. Okay, so let's solve this. So just like any other equation, I need to first go ahead and start to get rid of additional items that I don't need. So I'm going to first divide through by the 4,000. Okay, so those are gone. I'll be able to cancel out 3 pairs. 10/4 is 5/2, which is equal to 1 plus 6.45 divided by 200 to the power of 2n. Okay. Now, he's absolutely right. If I want to go ahead and mainstream this variable with the rest of the information, we need to go ahead and take the log. Okay. So 2n is my power. That's my exponent. No. Remember, if you could describe a logarithm in one word, it's a what? It is an exponent. It's a power. So whatever log expression you create, it would have to equal the power. In this case, it would have to equal 2n. So log equals power. And I just said it like that to kind of emphasize, power of the logarithm. Yeah. Anyways, this one right here, this is my base. And does anybody remember the third part that's always involved with a log or an exponential? Oh, somebody said it. Argument, yes. Okay. So if I were to take this exponential equation and I wanted to rewrite it as a log, then I'm going to go ahead and say log of base 1 plus 6.45 divided by 200 of 5/2. Remember, the thing about a logarithm, that 5/2 is not a power of that base that we plug in. It looks like it the way we've written it, but this is actually the input for your log. And then we're going to set it equal to 2n. Okay. Well, what would I do once I have the value of this on the left to solve for n? Yeah, just go ahead and divide by 2, right? So let me go ahead and type all this in. So let's see, log of 1 plus 6.45. So I'm going to come on over here to the calculator. Let me get rid of this real quick. So if you hit Control and then your 10 to the X button right here next to 1, it gives you a log with your spaces. So it's parentheses, 1 plus, let's see, Control divide. What was it, 6.45? Divided by, was it 200? Okay, there we go. And then I'm going to go ahead and plug in the 5/2. Okay, 5/2. Okay, so I'm going to push enter. Okay. Now remember, this one here equals 2n. So in order to solve for n, I would take that answer.
Wait, no, this is that.
No, that's 2n. We haven't divided it by 2 yet. Remember, this is just the left side of the expression. So if I were to...
Oh, I get that. So I was looking at the financial calculator.
Well, remember n
Okay.
in the calculator is the product of N and K. So you
Yeah.
have to take one
Oh,
of
it
the
is.
and divide it by
Mhm.
two.
Ooh, that makes sense.
Okay. So this right here, I'll just say like 28.9 is equal to 2n. So to find the number of years, we'd still have to go ahead and divide that. Okay. So let's see here. Answer divided by 2. So we're looking at about 14.4 years, okay, for that to happen. Would everybody agree?
Why did you go with the log? Isn't it easier to do it just like with the insult? Not like
You could, but then you miss out on all the fun of solving the equation. And then being able to say, hey, look what I did. Okay. Yeah, the thing about logs, their bark is worse than their bite.
Yes.
So trees have bark. Yeah. It's a saying. Okay. All right. But, Michelle's absolutely right. I mean, we did go through and solve it by hand, but if I had just plugged it into numerical solve, I mean, it would have given me the same answer in seconds. Okay. Does anybody want to see me plug that in? You do want to see it? Okay. So we got about 14.4 years. Okay. So I don't know. Would you think that's a good or a bad thing? If you started with 4,000 and it took 14 years to get to 10,000.
That's a long time.
You don't need that 4,000.
I mean, that's the thing about and that's really at a high percent. I mean, if you were to do this much more realistic, I'd be kind of afraid to see what that number would actually be if you were to do it realistically nowadays. But I think the most important component is the time. Just don't touch it, leave it alone, let it do its thing. Okay. Let me go ahead and plug that into numerical solve. Okay. Okay, so menu, algebra, numerical solve. Okay, so we had 10,000 equals 4,000, parentheses 1 plus, okay, control divide, was 6.45 over 200, okay, to the power of, I'm going to put this in parentheses. I just always like parentheses. So then I'm going to go ahead and put 2x, okay. Now I'm going to get out of that. I'm going to push comma, because with numerical solve, you always want to go ahead and push comma, x, or whatever variable it is that you're solving for. And then as soon as I push enter, 14.4. Okay. So see, it did calculate it a lot faster, but I can tell just by looking at your faces, that was nowhere near as much fun. Okay. Right. Questions? Anybody confused by compound and simple interest? Okay. All right. Well, next up. And I think these might be our last ones. Yeah, because then we get to the assignment. Good, 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 good. Finding the annual rate of increase. When comparing two investment amounts, when the present and final values are known over a particular time period, it is possible to calculate the annual rate of increase. Okay, so here it's the same type of problem, but you're just solving for R. Okay, so let's set this up. Or in fact, did you want to try one on your own? Okay, let's try one on our own. Okay. So this one here, you're trying to solve for R. 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 Okay, so here's the problem we're working on. If I get Iman, would that be the correct way to say that?
Sure.
I just want to make sure I'm pronouncing it correctly. Okay. Mr. West is politically correct. Okay. Deposits $5,000 in an account that compounds interest monthly. And 2.5 years later, the account totals $6,000. What annual rate of interest was paid? So the amount of time I'm going to give you, I guess, kind of depends on this next question. How many people are going to solve it by hand versus just typing it in the calculator? How many people are just going to type the equation in the calculator? Okay, so maybe a little more than a third. Okay. Okay, well, you may not be done, and that's okay. But as long as everybody set up the equation correctly, whether you're doing it by hand or on the calculator, hopefully we're coming to the same conclusion. Does anybody want to go ahead and tell me what they got before we get started? What interest rate was Iman getting? Okay, Spencer, what'd you get?
7.32.
That's what I got, 7.32%. Okay, so let's go ahead and plug in everything that we have. So we're starting with $5,000 times 1 plus, we have no idea right now, let's say, what the interest rate is. So how many times are we going to compound it a year? Monthly, so K is equal to 12 times 100. We're going to divide that by 1,200. Now remember, the power is a product of the number of compounding periods and n. So that's going to be 12 times 2.5. What's that give me? 30. Okay. And with this interest rate, we're hoping in the 2.5 years to get $6,000. Okay. So somebody walk me through this if I were to solve by hand. Okay, Emily, what'd you do? Okay, so let's go ahead and divide by 5,000. Okay, those are out. So that ends up being 6/5 is equal to this. Okay, now what?
Take the take the 30th root.
There you go. So you can do one of two things. You've got 6/5 is equal to 1 plus r over 1,200 to the 30th. Okay, the only way you're going to be able to manipulate that base, the 1 plus r over 1,200, is you have to get rid of that 30. So, just kind of think about the old rules of what's going to get rid of a square root. A square, because they're inverses, right? So if I had a cube, I would use a cube root. If I had a 10th root, I would use a 10th. See how they're always inverses of each other, no matter what you choose? So if I want to get rid of that 30, I'm going to go ahead and apply the 30th root. Or you could just raise both sides to a power 1 divided by 30. Okay, did anybody out there do that? It's going to have the same effect because you remember how you rewrite a radical as a fractional power?
Just when I'm rolling. Oh yeah.
Yeah, you just take the power on your variable and divide it by the root, the index that you have. I don't know if you want me to go that far into it, but is everybody okay with this right here? So the 30th root and the 30 are going to cancel. So I've got, let me give myself a little bit of room here. I've got the 30th root of 6/5 is now equal to 1 plus r divided by 1200. Okay. And then where would I go from here? Okay, so subtract the 1. So the 30th root of 6/5 minus 1 is equal to r over 1200. And then let's multiply through by 1200. Okay, so that's going to give me the r that I need. And let's type this in and see if I get that 7.32. So I'm going to say 1200. I'm just going to go ahead and put this one in parentheses. Times. Now, if you want an nth root, if you go ahead and hit Control and then the caret button, it looks like the top of a house right here, it'll give you a radical, but you can put in whatever index you want. So I want the 30th root of, it was 6/5. Okay. Make sure I'm outside that radical. And then it was subtracting 1, right? I believe that's it. All right. And as soon as I push enter, bam, there's my 7.32%. Okay. Very good. Very good. Or you could just type it into numerical solve and it's going to find it for you the same way. You want me to type it in? So let's see, menu. Let's see here. Where'd I go? Algebra. Yeah, numerical solve. So let's see. It was 6,000 equals 5,000. Parentheses 1 plus. Okay, I'll just change that to an x over 1,200. And I'm going to raise that to a power of 30. Okay. Make sure to cursor out of the power, control, or not control, comma, x. I haven't forgotten anything, have I? Don't think so. So as soon as I push enter, oh, interesting.
If you just put it in as 1 plus x and then multiply it by the denominator, you should get an answer. I don't know why it won't do it like that.
That's interesting. Yeah, I don't know. So if I just have and if I had the 1,200 outside of that, what'd you say?
I just took a fractionated 1 plus x and then got that answer and then did 1,200 times answer.
Oh, okay.
And got it.
Interesting. So no, I don't know why it's doing that. That's a good call. All right. Okay. So if we were doing it in the calculator, what would be another way to do that if you didn't want to solve it by hand? Financial calculator, yeah, that would work. Did it work out?
Yeah.
Oh, there you go. Okay. Perfect. Okay. Well, there's only one little bit of information left, and then we are done with this guy here. Okay. Okay. All right. So I'm just going to go ahead and give you what I got. You can like check that. The only thing I want to go ahead and talk to you about is this last section here. It says depreciation. When a car, piece of machinery, office furniture, etc. is used, it's going to lose value over time due to wear and tear, obsolescence, and other factors. We say that it depreciates or decreases in value. So you're going to notice, again, what I was talking about with Libby just a little while ago, it's the same formula. Okay, you're looking for the amount that's going to be lost per year. If I take off the minus C, then it's going to give me just the total amount that it's lost. Okay, or excuse me, the current value it is right now after so many years. If I go ahead and subtract the C, then that's just how much it's lost. Does that make sense? The only difference here is that R has to be what? Negative. In fact, that was really useful when dealing with exponentials, and you may remember why PERT was so important to us, why it could both represent a growth and a decay function. Because even if you have a growth base, something larger than 1, it could be a decay if the power was negative. Does that make sense? Does anybody want me to kind of show you that graphically, or does it matter? No? Okay. Let me go ahead and give you the answers on these, just so you can take a look at them, if you'd like to. Photocopier was purchased for, because we got a few minutes left, $12,500, and it depreciated at 15% each year. By how much does it depreciate in 1 year? So in 1 year, it should be losing $1,875. Okay, and that's if you go ahead and subtract off the original amount that we had, the $12,500. Okay, all right, copy that. Copy Joe. Not one of my stronger ones, but I'll still stand by. Okay, now this one, find its value after 5 years. So what you can do is go ahead and subtract off the original amount. Or actually, no, not subtract off the original amount. That's gonna, I don't know what I'm saying. Okay, so has anybody actually already solved this problem?
Yeah.
Okay, what'd you get? 5,546. 32, that's what I got. Okay, good. So it's the same formula, it's just the fact that R is negative. Okay, all right, good. Now, will compound and simple interest be on the test tomorrow? Yes. No, I'm kidding. Remember I said I removed that. Okay. So it is not. Everything else will be. All right. So I will be here in the morning if you have any last minute questions. Thank you.